Once scoping is out of the way and you have all of the requirements documented and permissions approved, you can move on to the reconnaissance and enumeration phase of testing. There are different types of discovery that can be performed. For instance, you will want to be able to understand how much data can be collected in a passive manner. Passive enumeration indicates that you will not actively interact with the target systems. You may also want to perform an open source intelligence gathering, which will take advantage of services such as Whois, social media networks, and any other third-party service that is able to provide you with information about the target. This activity is really hard to detect for businesses and organizations, and as such is very low risk for an attacker. Once that has been completed, you can start to take an actual look at the targets. This includes the identification of ports and services that you are running, understanding the applications that are available to you, and getting an idea of what the infrastructure looks like. Let's take a look at each of these in greater detail for a moment. Passive enumeration could involve the collection of details using techniques such as network sniffing. Network sniffing tools such as Wireshark will allow you to passively gather information about the network. This capability will then enable you to store network traffic for later analysis. Perform passive network discovery. By reviewing the data that is being transmitted across the wire, you will be able to detect several different patterns, some of which will lead to providing you with the ability to discern relationships between assets, as well as providing you with some indication of which operating systems are being used on the network. Network sniffing is also beneficial in activity monitoring, where you would be able to provide the organization with data that they could then later review to see if assets found are authorized to be on the network or unauthorized and potentially a threat to the environment. Depending on the capability of the tools you are using, you may also be able to perform vulnerability detection. By this, I mean that you will be able to identify situations where there is usage of things such as unencrypted traffic, clear text authentication, or even malicious traffic signatures. The location of where you are capturing network traffic is also important. For instance, you could be on the perimeter where you have little to no insight on internal traffic. Or you could also be behind firewalls, where you will see more traffic since packets are not being dropped. A lot of this will depend on the infrastructure design, however. In most cases, you will only see the broadcast traffic for your domain, unless you are combining network sniffing with other attacks that inject you into the line of the traffic. You could also perform network traffic sniffing behind security devices such as IDSs, or within critical network segments that have a lot of broadcast traffic. These would be the ideal candidates to collect data while performing network sniffing. Open source intelligence, commonly referred to as OSINT, is the practice of collecting data that is available on the internet or other publicly available sources. This data can often tell you a lot about an organization and the types of vulnerabilities that they might be susceptible to. It can also be used as an input to many other attack types, especially social engineering. Some of the tools used to perform OSINT include search engines. Yep, you heard me correctly. Many attackers have perfected the art of searching and are able to extract extremely valuable data from search results. This includes documents that the organization has publicly available, critical dates and times, and all sorts of other information that can be easily found by anyone in the world. Social networks are also a primary target for gathering OSINT. People sometimes give out way more information than they should. This information can be used towards all sorts of nasty attacks down the road. Some other tools used include ReconNG, which is one of my personal favorites. It collects all of the data for you and then provides it in a nice and easy-to-use format that fits perfectly into your reports. Maltego is another tool that many people enjoy when performing OSINT activities. It has a very nice graphical user interface and allows for many powerful modules. Meta-Goofle can be used for identifying metadata stored in files. And Shodan will provide you with information that the Shodan team had gathered in previous scans of the Internet. This will include system service information, banners, and much more. This list is but a small sample of the types of tools that are available to penetration testers and attackers alike in regards to OSN. Active enumeration and discovery also allows you to move towards more intrusive detection capabilities by performing activities such as ping sweeps, where you'll be able to use ICMP to identify responding hosts. Port scans to identify ports that are actively responding to requests. OS fingerprinting to understand which operating systems that you are targeting. Service identification and version scanning. Banner grabbing. Browsing web applications using proxies. And enumerating information providing services when they are available. These could include services such as DNS, SMTP, and SNMP. During active enumeration, you will also need to determine if there are any security controls or protections in place. These could include items such as IDS, IPS that might interfere with the next phase of the penetration test. Tar pits that slow you down when performing enumeration attacks. Firewalls that may need to be bypassed or that might cause your enumeration steps to come back with odd results. Web application firewalls that may attempt to block you from certain activities. Or access control lists that might prevent you from identifying active services or live hosts. You may also need to be concerned with host-based firewalls that will attempt to limit access to the host itself.